There we go. Good evening, everybody. Those of you that are with us tonight and the many more that will be with us in the future watching this on our YouTube channel. It's with great thanks that we give both Andrew Thomas and Richard Knott, who have put this presentation together. And it is really an absolutely getting started. So if you join us with very little knowledge about how to connect the Raspberry Pi to a Windows computer, or have little knowledge about the tools that are required, file transfer and the associated applications, then you are in the right place. Anyway, you don't want to hear me all evening giving the extended introduction. I'm going to hand straight over now to Andrew Thomas.
Okay, I'm just going to do a very brief introduction. Those who are looking at the gallery can see that we have a Raspberry Pi, which is not connected to anything other than the electricity supply. And I quite like the Lego case. So the next thing we're going to do, there are copious notes have been prepared for this. Richard will explain where they are for downloading online, which will explain everything in minute detail. What I'm also going to say is Paul is right. If you know a little bit about a Raspberry Pi, we may be starting a little bit what you might see as below your working level. But I hope if anyone is an expert and a Linux expert or a Unix admin, you might be on the wrong course. But will take you from absolute basics of not quite how to buy a Raspberry Pi, but how to turn a Raspberry Pi into something you can use. So I'm going to share my screen. You should now all be able to see a nice clean desktop on a Windows PC. So the first thing, once you get a Raspberry Pi, it actually doesn't do anything until you load an operating system onto it. There will be links in the documentation to all the things we refer to. So, for example, Raspberry Pi is bending over backwards to be user-friendly. It's got extensive help. Richard just posted in the chat where the help is and the documents are. It's got extensive help online and it's very clear, it's very user-friendly. So the first thing you need to do is to find a piece of software and download it called Raspberry Pi Imager. I won't do the whole downloading and installing bit or we'll be here all night. So I will fire up Raspberry Pi Imager. And here we will say yes, because we want it to run, and there it is. I'm now just going to go and call up my crib sheet. Now, the first thing you need to know is what Raspberry Pi device you purchased. Again, we are taking this from a very basic level. The Raspberry Pis we're using for this demo are both Raspberry Pi 4Bs. The 400s, compute modules, they all have the same operating system. So we select Raspberry Pi 4. We then choose the operating system we want to load. And as you can see, scrolling down here, there are lots of them. There are special purpose ones, emulation games, home automation systems, but the one we want is right at the top, recommended Raspberry Pi desktop. That's the user-friendly version. The version without the desktop, I believe by the end of this, you'll have a good idea how to use it, but it's not user-friendly. I'll now plug some storage in. Find the USB port. Get rid of annoying messages. And choose where I'm going to write it to. We'll now do the clever part. Click Next. would you like to apply a custom operating system customization settings? And this is the important bit. This is the bit that makes your Raspberry Pi usable from its first power up as a headless device. So click Edit Settings, and this is the key screen. So the first thing we'll do is we'll set a host name. Now this will be the name of your Raspberry Pi. It helpfully suggests that you call it Raspberry Pi. Now, if you have one, that's fine. If you have several, that becomes very confusing. So I'm going to call this one, Muon Pi, because that will match what you'll see in the documentation. We'll set up some usernames and passwords. We'll call it Pi. Now you will see on the one I'm using for demos, it has a different name. You can call it anything you like. Type in a password. A nice, long, complicated password. Now the important bits. Configure your local wireless LAN. If you do it now, as soon as you power it up, it'll log straight in. So pop in your, I've called it mine demo net, but your Wi-Fi will have a name for its identifier, and it'll have a password. And again, I hope you have nice, long, complicated passwords. We're in the GB, so we'll leave that. I recommend to you that you use some localization settings. And the important one, I recommend that you use somewhere down here, there is a setting to make it UTC. As we're doing astronomy, and everything we do will be in UTC. Somewhere in here. Here we go. It's called etc. UTC. That way, it will always be an hour behind British summertime, and it will always be right during the winter. But I would recommend that if you're taking observations, use UTC. This next screen called Services, click Enable SSH. Now that is the secure way of logging in over your network to your Raspberry Pi. So if you turn it on now, you'll find you never need to connect a keyboard and a screen and a mouse to your Raspberry Pi to enable this secure connection. Use password authentication. That will use the passwords and the username you entered on the last screen. Options, you can choose whether you want it to play a sound or whether you uneject the media when it's finished. Now I'm going to say save. What I'm not going to do is to apply this to an SD card because it's like watching paint dry. It can take about 15 to 18 minutes to do. But that's the process. If I clicked yes now, it would start writing an SD card. So I'm going to say, no, I don't wish to continue, and we'll move on. I'm more than happy to take questions as we go along. So after each little section, let's take some questions. Anybody got any questions? Well, that was either incomprehensible or hit the nail on the head. Excellent. So the next stage is the fairly obvious one of taking the SD card and plugging it into your Raspberry Pi. plug your Raspberry Pi into a USB power supply, and off it will go. And the next thing you'll want to know is it working? Is it connected to my home Wi-Fi? So how do we identify it on our home Wi-Fi? There are tools for this. I use a thing called Angry IP Scanner. And at this point, I will say lots and lots of other IP scanners can be downloaded off the internet. And pretty much they all do the same thing. And I'm going to do this, not because we absolutely have to do this, but because it's an easy thing to do, and it's quite useful if you ever have to start fault finding or think your Raspberry Pi has failed and it's raining and you don't want to go down the shed to see what it's doing. What this will do is it will ping the entire address range of your local area network, which will either be something like 192.168.179.0 to 255, or it'll be 192.168.1.0 upwards. So I'll just pop it on to start, and there we are. It's found a router. It's found my PC, which is a god of mischief or a pain in the neck. And it also has, here you go, here's my demo Pi. And it's got a suffix of .fritzbox.com. Now, Fritzbox is the name of the router company that my ISP supplies my router from. But for practical purposes, in the next step, you can ignore that bit. It will happily identify it as demo Pi, or whatever you called your own Raspberry Pi. So now we know it's there. It's out there on your network. And the next bit of software we're going to use is, some of you may have come across this before for other things, especially if you upload things to FTP sites or websites. It's called WinSCP. Again, there are full instructions of how to install this in the course notes. Oh, here we go. Here it says hostname demo Pi. We know it's a host name because we set that on its SD card in the last section. Its username is demo. I know it's called demo because that's what I set when I blew its SD card. And its password is not quite password, but demo password. And if I've typed that correctly, I can now press login and the Raspberry Pi will appear. And with some relief, we've logged in first time. Now, what we're looking at here is a piece of software that's designed for uploading files between different machines. So on the left-hand side, you have your host, your end, the end you're working from, your PC. So if you look at that, we're looking at my desktop. And you can see on the desktop, there's a folder called Tidy Up, Angry IP Scanner, a little bit of Python called Find Ports, a bit of software called Putty, and the Raspberry Pi Imager. They're all there. So that we know is the machine I'm working on, the PC end. The other end is called Home Demo folder, and it's got a set of subdirectories in it. That demo is the host name of the piece of the Raspberry Pi that I've connected to. So what you've got is two panes, your end and the far end, and it works very, very much as in almost identically to Windows File Explorer. So you can navigate round to different directories. And if you were looking at, and you will do later, looking at the desktop view of the Raspberry Pi, you would see a desktop with nothing on it because there's no files here. If we go down to here, with a directory I've created called Muons, find ports. I've got a little bit of Python in that directory. And that is the simplest way of getting logged into your Raspberry Pi. If for any reason on your network you find typing the host name, either it's short form like I did, or it's whole long with the router name attached, if that doesn't work, use a network scanner and use its IP address. Those 4 blocks of digits. Type it exactly as it appears in the scanner, and that's another way of logging in. It still needs a password and it still needs the username, but it's another way of identifying the device. On networks, sometimes you will find that things that should work for no reason you can put your finger on easily don't, but an alternative will. So it might depend on what security software you've got running on your PC. It might just depend on how your router is configured by your ISP. There can be differences, just a little warning. So there we are. We are here. You can do a few other tricks from WinSCP. You can launch a little application called Putty. Now I've got Putty over here as a standalone application, but you can fire it up from within WinSCP, and that saves you a little bit of typing. All you have to type is the password. And you're now logged in to the command line of your Raspberry Pi. Now this is where it's this can be quite daunting. If you have not got a lot of experience using the command line in Windows, and generally there's very little need to ever find out how it works, this very bare bones hair shirt way of working can be quite daunting. And there is a huge array of commands that you can use, and it can be at first sight very complicated and very daunting. We'll put a crib sheet of the commands you can use at the command line up in the course documentation. There'll also be a link to the site you can download it from. There are lots of these crib sheets out there on the internet. They're all slightly different. They're all very useful. And if you ever get stuck, go to Google, type in Raspberry Pi and how do I make a directory, or what does this command mean? And it will tell you, you will find a website that will tell you all about the subtleties of it and how to use it, even if you've just forgotten temporarily. So here we are. We're looking at the rather daunting hair shirt command line. Let's type a command. It's called IPconfig.
IPconfig.
Thank you. It helps if you can A spell and B type. Now this is a useful little bit of code that will tell you all about your Raspberry Pi and its configuration on the network. And somewhere in here is its IP address. So if you can't find it another way, you can ask your Raspberry Pi what its address is, and that is quite useful. Once you've logged in here, you will find out what's going on. Now you're here, what can you do? Well, everything you can think you can do let's go back onto a Windows laptop. You want to make a directory. You fire up Windows Explorer, File Explorer, and you make a new folder. And it's all a matter of clicking on buttons with the mouse and typing in where a new folder appears on the graphical interface. We can do all of those things here, but you have to type them out in full. So for example, over here you can see, for example, we have a directory called Muons. So what I'm going to say type here is change directory and its name. And you can see here in blue that we're now in the, this is my home demo py, and I'm now in a subdirectory called Muons. And you'll always get these things, the little slash there that tells you it's a directory. They turn up everywhere on a Raspberry Pi when you're looking at directory names. What can we do when we're here? Let's see what's in the directory. Type dir for directory. It says there's a file there. There's another command that appears to do exactly the same thing. ls, list, find ports. Tells you exactly the same information, but list, ls, can do other things. If I type a dash L, which is a sort of qualifier that tells it to do that, it now tells me everything there is to know about the file called findports.py. Who's got permission? Who owns it? Who can run it? Who can edit it? Now, most of the time, you don't need to know that in great detail. But when you suddenly find you can't edit a file, you might want to know why. And permissions to edit things on a Raspberry Pi are quite complicated because it wants to protect itself from the user. There is an override for that, and just a word of warning, if you start poking around in directories that are part of the operating system, you can delete things that you probably shouldn't delete and it will stop working. It could be easily fixed by making a new SD card with a new operating system, but I promise you, it is very annoying when you do it. So do respect it. What else can we do here? We can go back up the directory tree. cd ... I'm now one directory above where I was before. And if I type ls-l, I can now see all the directories, all the files in that home demo directory. And it will tell me who's got permissions, who's the owner. It's straightforward to walk your way around, but you do have to, sometimes you do get a little bit lost. And sometimes just using that cd space ... and going back up until you get to your home will put you back. It's not as intuitive as using a graphical interface. The other important things you can do here, and I won't do them because it'll waste a bit of time. This is where you can easily shut down your Raspberry Pi, turn it off. It's quite important that you don't turn it off by just yanking the power lead out. Linux systems can, on Linux-derived system, can and do sometimes go off and corrupt themselves if you just pull the power out. Raspberry Pis are very tolerant. They seem to have been designed to put up with that sort of abuse. So if you just pull the power lead out, it will usually work again. There are other similar mini computers, for example, a BeagleBone, If you do that to a BeagleBone, it won't talk to you again, ever. You have to make a new operating system for it and generally be nice to it, because if you just pull the power out, it will corrupt its operating system. So, word of warning, how do you turn it off? Right, there is a magic command, sudo superuser do, because, as I said before, the Raspberry Pi wants to protect itself. If I just typed shutdown, it wouldn't do anything. I have to tell it that I've got permissions as a super user to issue the shutdown command. And shutdown, you will find this command all over the internet, -H now. If I press return, it will ask me for a password, and then it will execute that command. I won't do it because I don't have to start it up, and that would waste a bit of time. That, as I say, that command is all over the internet. It's a standard. It's in the Raspberry Pi help, but that is the best way of shutting it down. If you just want to reboot it, the command is reboot. There are some really nicely obvious commands for the command line. So sudo reboot. If I press return, I will get asked for a password, and then it will then execute that command and reboot my Raspberry Pi. Again, if you've done something and it's sort of locked up or won't take any input, doesn't appear to be wanting to stop its program, that's quite a good one. Shut it down and start again. So there's some important commands. There are a multitude of others. I think there's about 70, 75 odd in the crib sheet we're going to dish out, which will let you do all the basics. But the basic things you'll want to do is perhaps reboot and shut down, see what's in directories, make a new directory. You can copy files from one location to another, and that's a very useful one to be able to use. You can find out what it's doing, see how busy it is. Richard might demonstrate one or two commands that tell you about how its performance is. So that's the scary command line out the way. And at this point, I'll hand over to Richard and he'll show you how to get into the nice, pretty, easy to use desktop. So I shall stop sharing.
Thank you very much.
Any questions on that just before we move on? Excellent. I'll mute myself. The floor is yours, Richard.
Good. Hopefully everybody can see my screen. There was one part that Andrew omitted, and that is that I want to use a piece of software called VNC Viewer, but we have to enable it on the Raspberry Pi. And the way that we do that is by using a piece of software like Putty or WinSCP, as Andrew has shown you how to log into it, to be able to gain access to the Raspberry Pi. I'll just go through that if I may. I'm going to show a couple of ways. So if I type my user name, i.e. I've chosen Pi, and then my name of my Raspberry Pi, using Putty, I can go into that. It's asked me for the password straight away. It doesn't ask me for the user. I can take my password in. My password is password to make it nice and easy. And there's a command to be able to configure your Raspberry Pi, and that is sudo raspi-config. All this is in the notes for you. And this will bring up the Raspberry Pi configuration screen. We just need to use the down arrow to come to number 3 and press return. And we then go down 1 to get to I2, which is for VNC, and we press return. And it says, would you like to enable it? Yes, I would. It will then enable VNC virtual network configuration on your Raspberry Pi. We can then press OK. And I'm just going to use the Tab key to move down to the bottom two choices. I'm going to select Finish, and then I'm going to type Exit because I don't need to use my Raspberry Pi anymore. Sorry, don't need to use Putty anymore. I'm then going to run a piece of software called Real VNC Viewer. As you can see, I've got no connections, as you would have. So I'm going to create a connection. I'm going to call it pi@muonpi.local. I'm going to give it a nice name so that I can work out what it is. I'm going to click OK. It's going to put a connection here for me. If I double click on that connection, I've obviously made a mistake, and I will make another connection. Let's do it this way. I'm going to be asked for a username and a password. For me, it was pi and password. Please don't use password. I'm going to click Remember Password. It's going to take me into the desktop for the Raspberry Pi. Now, this has very much a Windows feel to it, which is rather nice for us that are used to using Windows applications. So if I press this here, File Manager, it's going to open up a nice window for me that I sort of feel that I know what's going on. It's got documents, download, music, pictures, etc. And I can use similar mouse key commands as I would be using with Windows or within Macintosh. So if I right click on my mouse, I'm able to create a new folder. I'm going to call it Muons. It's created a new folder for me. If I move to the top of the screen, I get a X that comes up, and it enables me to exit from this platform. And I want to do that. I want to just try and do that because I want to show you something that we can do with VNC. So if I exit it, it says yes. Now you can see there's a pretty picture on my desktop. It gives me some better idea of what Pi I'm actually connected to. I'm going to right click on there and select Properties and scroll down. I'm going to undelete the Update Desktop Preview automatically and click OK. It's going to say, do I want to remove the desktop or keep it? I want to keep it. So my Pi's picture will stay the same. If I double click on it again, I automatically go into it because I said I was going to save my password and username. So what can we do with this? Clearly, we've got exactly the same sort of Windows-based commands that we had before. I can go into a folder. I can create a file by typing new file. It asks me for a name. If I want to create a document, I can do it that way. So where do we want to go from here? Well, clearly we want to get some files. And VNC doesn't enable you easily to move files from one place to another. And the place that we are suggesting that you have a look at is the GitHub repository that I have shared with you. I can go to GitHub on the Raspberry Pi, and I can get into the repository that I showed you, or I have pasted the link for. I don't have a very fast internet connection through my Raspberry Pi when it's using this interface, unfortunately. Please bear with me while it gets to it. But we should then be able to, once we have got to GitHub, I assume that everybody's trying to get to it, we should be able to navigate to Ukra's download page and then download the information that's there. That's what I really wish to be able to show you. Does anybody have any questions? If so, please raise your hand using the raise hand command, or put something into the chat for Andrew and myself to be able to respond to. Andrew, I'm having a bit of trouble getting the GitHub. Would you like to go forward to show how you can transfer a file using WinSCP? Or are you having trouble as well?
No, I've just forgot to unmute mute myself. Right. I'll show the local file transfer. And
yeah.
Has it not got an internet connection?
No, it has got an internet connection.
Right. Share screen, share screen, share screen. Right. Back where we left off. The key functionality of WinSCP is file transfer. That's probably what it was invented for. And it is simplicity itself for moving files between your local machine and your local Raspberry Pi. And I will simply do it. What I'll do is I'll make a new directory. So up here in the usual kind of Windows-like interface, new directory, and I will call it Muons 2. Voila, there we have Muons 2. And I'll double click on it. There's nothing in it. So if I now do a simple drag and drop, there's a file. And that we will build on this type of functionality in the next sessions, where Rupert is going to show a way of using software to develop Python from your nice PC with its big screens, big nice keyboard and mouse, and have them running on the Raspberry Pi without having to go through intermediate stages. And this would be one of the intermediate stages, to copy something from one directory on your PC to a directory on the Raspberry Pi. And that is the core functionality. You can make directories, you can navigate. If I keep clicking up the directory tree, I would get into the root, what is called in Raspberry Pi Linux world, the root. And these are all operating system directories. These are all places where potentially you can do some damage. So we will go back to our home, demo, and Muons 2. There we go. That's the core functionality of WinSCP. So maybe we can go further. Let's just double click on this file and see if it runs. No, that's a step too far. What it has done is open the file up in a simple text viewer, and you can see what's in the file. And that will pretty much work for other things on here as well. So if I wanted to run it, how would I do that? Well, I'll show you the hair shirt way, which is to get on the command line, change directory to Muons 2, list it to see what's there. Here we go, find ports.py. Let's run this program and see what it does. I will type Python, because that's the language it's written in. Python is pre-installed on a Raspberry Pi. It's part of its basic operating system. Find ports.py. Now, what that's doing is it's asking the Pi what have you got connected to your USB ports? What USB ports have you got that have got devices connected to them? Now, if you look on the other, my little picture, you should be able to see that I have a Raspberry Pi and I have a muon detector. What I'm going to do now is plug the muon detector into one of the get rid of Dropbox. Right, I now have a muon detector flashing away plugged in. If I now run this software again, and here's a trick in the command line. I'm going to press the up arrow on my keyboard and it shows me the last command I've run. I press it again, it shows me the command before that and so on, all the way up a stack of all the commands you've typed in. So let's run it again. This time we've got a different result. Your operating system is Linux. Now that is the same as it was before. Here we have that bit, and this again, this is the way Linux works. That is a USB port. Technically, it's the file that defines the USB port, and that is in a directory called dev in a file called tty USB 0. So if I wanted to read from that muon detector in the future, the first thing I plug in is always USB 0. It doesn't come up on a random number. Windows, it depends which USB socket you actually plug the wire into. No, first device in, it comes up as 0. Second device plugged in, it comes up as 1, and so on. You've got 4 USB ports. If you plugged 4 devices in, there'd be 0, 1, 2, 3. And that is pretty reliable, which is great. When you plug a keyboard in, it doesn't turn up because it doesn't see it as a device attached to a USB port. It sees it as a keyboard. So there are some subtleties around the way a Raspberry Pi relates to the outside world through its USB ports. There is a lot of stuff online. You can delve down the rabbit hole of Linux USB ports. It gets more complicated, but this is the simple version. So that is how you run a program from the command line. Are you winning on GitHub, Richard?
Yes.
Right. Well, if anybody got any questions about the simple way to run programs from the command line? Right. All yours then, Richard.
Okay, so I have been able to get into the link that I sent to everybody at the beginning. This is where we have put all of our training resources for you. There is the Creating a Headless Raspberry Pi PDF document that you can download and review at your leisure. There's a lot of information there. You don't have to read it all. I've also got a couple of other folders. I've got an Arduino folder where I've got a modified OLED.ino file, which puts commas in between the data as opposed to having spaces, should you wish to produce comma-separated variable files. I'll show you how to download the Python code. The same would be true for this. So it's a slightly different one from what you will have seen elsewhere. I'll go back to Python training main folder. If I go to Python, there's lots of software code on GitHub. You don't need to have an account to be able to access it. You can peruse it and find some information, but it seems sometimes very difficult to work out how do you actually get that information. Well, there's a couple of ways. I have got the same program as what Andrew has just showed you. I've just called it USB scanner. If I click on USB scanner, it will take me to effectively the code, which is written here. And there is a download button. It's the third one along next to raw. I can quite happily press on the download. It will now download it directly to my Raspberry Pi. So if I go to my Windows directory, for want of calling it something, you will see that I've got a downloads folder, similar to what we would have on a Windows PC. If I double click onto that, you can see that I've just downloaded that program there. I can open it, and I've right clicked, and I'm going to choose Putty. I could choose something else. This is a integrated development environment that enables you to run the program in a slightly different way to which Andrew showed you. But you can see that it comes up with the same sorts of things. I clearly am running two Muon detectors at this moment. One is in USB 0, one is in USB 1. Let's just minimize that and go back to GitHub. I've also modified or made a modification to import data. I've called it import data mod. If I click on that, it's going to take me to lines of code that look very similar to the Cosmic Watch program. I've removed the ability to use SD cards. I've removed the ability to upload data to MIT because I've not been able to get that interface to work. This really relies on your Muon detector just running the OLED screen. Again, I can download this, which it has just done. I can go to my downloads folder, and it's put it into my downloads folder. I'm now just going to copy it to the Muons folder that I created earlier. I'm going to left click on it, right click the mouse and do copy. I can then go to my Muons folder. I'm going to put the mouse into the Muons folder. I'm going to right click on my mouse and do paste, and it's put it there. Now, Andrew showed you that we can open up terminal windows, and clearly I can do a long list so that I can see what directories or files are available to me. I want to change my directory to Muons. One of the tricks Andrew didn't show is that if I just type the first letter and there isn't any other conflicts, if I press the tab key, it will auto-fill it. So I've moved into my Muons folder. Again, as Andrew said, the tilde sign means home, / means I've gone up one directory and I'm in the Muons directory. Again, I can do long list, and I can see that my import data mod.py is there. Why don't we run it just for a little while so we can generate some data? Again, I typed I as my first letter and then typed tab. I can't type that fast myself, and I can run it. So what do I want to do? I want to record data. I'm going to use two detectors, 1,2. I'm going to just keep it as the standard text file. I don't need to change the name. It's only for demonstrations. So my two Muon detectors are now collecting data and storing it on the Raspberry Pi. How can I see that? I can see that it's now created a text file. Similar to Windows, I can go to View and I can change to List View, and I can see things that sort of mean sense to me, the size of something. I can move the columns about by moving the mouse over them and such like. We will see in a moment that it's just downloaded some data to it, and I can double click on it. It will open it up in a text editor, and we can see what we would normally expect from a muon detector. You can see that there are some differences, that I have commas that separate all of the different data files. Okay. Was there anything else, Andrew, that you wanted me to comment on at that point?
I was just going, am I unmute? Yes, I was just going to unmute myself and say the reason I didn't show you the tab trick is because I've just learned something. There are a lot of subtleties and complexities, and there is always something new to learn, which personally I think is great. One of the things what Richard has done is he's shown you the command line window, which is exactly the same window as you would see using Putty. You can do everything I've shown you through that command line window.
Through the terminal.
Now, through the terminal window. I think that is quite a good point of reference between the two ways of working. One of the things we wanted to show, as you could type faster than I can, Richard, can you show that if you start that program using the command line there, and it starts taking data, there we go. So if you now look at the size of the text file, that should start growing now as it takes data and writes to it. There we go. Just wait a little moment for it to update. What we're going to show is that when you close that terminal window, the data file will stop updating, that cwdata.txt, because when you close the terminal window, it closes the application that you're running within it or through it, depending on which metaphor you like. There we go. It's uploaded some data. Now, if we stop that terminal window, that will never grow. It might have written some data in the moment while we were talking, but that process that was reading from the muon detectors and writing to that file, cwdata.txt, has stopped. Now, you might say, what use is that? Every time I sort of close my window, it stops doing anything. So I'd just like to introduce a fairly straightforward command.
I'll stop sharing, okay?
Yeah, if you stop sharing, I'll do that.
There is somebody with a hand up. May I ask them what their question is?
Me, actually. Richard, you modified the Arduino code. Does that include the modification to force one of the detectors into slave and one into master, or is that a different?
The Arduino code that I have put onto GitHub just puts commas between the data points. I have modified the Arduino code for my own use that will force one detector to be a slave. I'm more than happy to push that to GitHub should people want to use that.
Yeah, David asked me at Winchester on Saturday, so I think that'd be useful for some people. Thank you.
Yeah.
Yeah, thanks, Paul. I mean, just briefly, the reason the problem I had is after a power cut, they didn't recover cleanly. So I think to have a fixed reference would probably be helpful for many people. Yeah.
More than happy to do that, David.
I quite agree. I have used that modification. So let's show you. I will use the same piece of code that Richard was using. I shall try and make my life easier by downloading it. Okay. Where's that? No, right. I'm going to now use WinSCP, which I'm going to point to my downloads file. and drag import data mod, put it in my Muons 2 directory. Now I want to run that, so I'm going to go back to my terminal window. I'm going to use, this is where I think programming and traditional magic, as in casting spells, has an awful lot in common. No hup. It's how you get no interrupt, which is what it actually means, to out of no hup, I don't know. You can Google this. There is a long explanation of how it works and what it does. So we have no hup. We type Python and we type the name of. Now what you do, you press tab. Oh, that's good. And then I type and PS. PS is a listing, and it's quite a neat way of just terminating this command. And what this will do is it will start running that piece of code, import data mod.py, and it will show you two things. One is that it should keep running even when you stop and close that window, but it will also show that there's a trap. So I'm now running a piece of code, and I will prove it. So if I type PS again, there's a list of all the things that are running on my Raspberry Pi. And if this has worked properly, which it hasn't, it's crashed. And that will prove two things. One is I haven't loaded Python on my PC, and I haven't loaded all the modules onto. And also, I have no way of putting data into it. I have no input mechanism. So this isn't a good piece of code to do this demonstration with. The message here is when we start writing Python, the code we're going to use won't be looking for user inputs. What we need is important to remember is that this concept of this no interrupt, if I used a piece of code that I use all the time, I would run it with this no hup command. And when I close my window and logged out of my Raspberry Pi, it would continue to run. And it will continue to run forever, either until the power fails to the Raspberry Pi fails, or the code for some reason hits an unknown, unanticipated error. And that no hup command is really very, very powerful, and it will turn up again as we go forward. The last little bit, Richard, was to talk about Microsoft Visual Studio Code.
I'm happy to lead on that.
You want to do that? Fine.
Yeah. So we're getting towards the end, and what we wanted to do was to prepare you for what Rupert was going to be able to do over the next 3 weeks. And I've demonstrated that you could program directly onto the Raspberry Pi using the Thonny interface. But what we're going to suggest is that you use a piece of software called I'm looking at it, Visual Studio Code. Now, Visual Studio Code looks quite frightening. There's instructions in the headless Raspberry Pi documentation on how to download it and how to set it up. And I just wanted to show a little bit about with that. I can take 5 minutes of your time. Let me share my screen. So I've downloaded it and I've installed it onto my system. If I double click onto it, it is a wonderful piece of software. If you want to do computer programming, you can do any language that you really want to use here. It's got an interpreter for it or a compiler for it. There are a couple of things that we need to include, and they are going to be called extensions. Clearly, we are going to need to have the the Python extension so that we can program in Python. And the way to find out what extensions are available is to use the extension tab that is on the left-hand menu, and it will bring up a search bar for you, and we can quite happily just type in Python. I haven't even pressed return. It's come up with some suggested extensions that we could add. The top one is the one that we will use. I've already installed it. If I click on it, it's saying that I can uninstall it if I so wish. Well, this is fine and dandy. I can clearly write a piece of code. If I go to desktop, I've got Python scripts. I can select this. It's going to enable me to do a new file. So let's do a new file. What do we normally have as the first one? We'll have hello. As you can see, I've already written one, hello world.py as my first script. It's asking me where I want to save it. I'm going to say create file, and we can quite happily type in a command. Straight in. The little white dot means that I've modified it. I'm going to save it by pressing Control S. And then to run it, there is a run function in the top right-hand corner. And clearly, if I run it, a terminal window is going to appear, and I'm going to run it in a dedicated terminal window. If I just press, sorry, if I run it as a Python file, I don't appear to have a interpreter for some reason. I had an interpreter this afternoon. What we should be able to do is to run that and load it and see it actually running. I'm not going to spend any time trying to work out where my interpreter's gone. Something's obviously happened from this afternoon to this evening. The second piece of extension software that is sensible to add is Remote Explorer, REMOTEEXP. And again, it will come up as the top one. We can see that I've already got it installed. I'm not going to uninstall it and reinstall it. What does this enable us to do? This enables us to speak to our Raspberry Pis over the internet without having to do any hard work. I'm going to get back to a welcome screen so that it looks a bit more easier for us to see what's going on. In the bottom left-hand corner, there is a blue icon that looks as though it's got a bolt of lightning going through it. If I single click on that, it brings up a command at the top of the window. I am going to connect to current window, connect current window to a host. Now, I have got my IP numbers of the hardwire and the Wi-Fi, but also my local Pi's name. If I click on that, it will ask me for the password for the Pi, and will take me into the Raspberry Pi. So I am now able to access my Raspberry Pi. How can I demonstrate that to you? I can do open file. You can see it says /home/pi. I'll do OK. I'm going to select downloads. I will do OK. Oh, sorry, we'll open a file. Let's open that. This was the file that was on the Raspberry Pi. I can change the code that's here. I can save it, and it is going to save it onto my Raspberry Pi. Let's show that in a slightly different way. Let's do open file, and I will choose this. So this is the scan and program on the Raspberry Pi. Let's add a line. Saying that I have changed the program. It's a information line. It's nothing else. I can save it, Control S. I can go small on that and go into my Raspberry Pi. And we can go to the downloads file. We can have a look and see which one I changed. I didn't change that one. I changed the other one. I can see that I changed it at 6 minutes past 8. So I'm going to open this in Putty. I hope. Putty's open. And scroll down. And there you can see that I have added this line here. It's what will be used in the next 3 sessions on being able to get information from our muon detectors, process that information from our muon detectors, and then graphically represent the information from our muon detectors. I'm going to stop sharing, and Andrew and I will take any questions.
I was just going to chip in and say the most important thing you can do with Visual Studio Code is change the color scheme to suit yourself. If you don't like working in the dark, programmer fashion, other color schemes are available, but they all do the important things, which is highlight variables in one color, highlight instructions in another color, show you when you've missed out a bracket or a comma or other sorts of syntax typing errors. It is incredibly useful. Any questions, or have we sent you to sleep?
And that was good. I also didn't know about the tab trick if you've got a unique first letter.
I'll ask one, but it may be a bit out of context, so just shut me down if inappropriate. Actually, not long after I'd bought the detectors, I set up the Arduino environment, and following the instructions on there's a couple of 2 or 3 sheets of paper I seem to remember now, where there were various libraries on the Arduino side that needed updating. I think most of those I managed to update, but 1 or 2 I couldn't find equivalents for, and they didn't exactly correspond with the with the versions on the document. It all seemed to work, but I was left with a sort of a slight question in the back of my mind, given I was unfamiliar with any of these things, and just what might be the problem. And then thereafter, the IDE sort of kept prompting me to say other more recent versions were available, but I don't actually know how critical any specific version is for doing this, so I didn't meddle. But it strikes me that there's sort of a complementary area, the software running on the Arduino itself rather than the Python stuff.
I would say you're in exactly the same position as I am. You obviously haven't. There is another peculiarity to the Arduino version we're using, that if you're a Windows 11 user, it will mostly prove impossible to connect to it, and I had to ferret around and find a Windows 10 machine. So be warned.
Oh goodness! Well, I'm running on macOS, so.
Oh, okay. You have other problems, but they're probably different.
They'll be different for sure. It just struck me as one of those issues that if somebody else did that too, then they would be left with similar questions.
Yeah. I have updated libraries at various times, and they have continued to work.
Okay.
It's the best reassurance I can give. Tony.
Hi there. Just a quickie. I've definitely learned, even though I've been using these things for ages and ages and ages, you taught me one thing very early on. I've never heard of this local, etc. /UTC, and I'm going to put it on my all-sky camera if I can find it, so I don't have this problem of it showing me the wrong time in the summer and getting all confused, because it has an hour of difference. Anyway,
Yep.
thank you very much for that. That's very useful.
Thank you for supporting that, because you can write your Python to work in UTC, but if you've got commercially available software for anything, generally it takes its timing off the device, and the device will override anything, and it can be. I've found that for the same reason you did. Got fed up with losing an hour's data.
Yeah.
Or getting
Thank
2
you.
hours data compiled into 1 hour.
Yeah, had that. I've had all those problems.
Yep. I like you, Tony. There's always something new to learn.
Yep.
Any more questions? I hope that was useful to people.
Yeah, I'd just like to say that do go to the GitHub repository, because Richard Knott's document is very comprehensive, and there's links to all the applications and tools that have been mentioned this evening in that document. It's well worth a read through. I mean, you don't have to read every line, but you can you'll certainly see the sections that you that you feel you might be missing out on.
Yeah, as I say, we pitched this for somebody who's never ever done it before, and as I say, I've been playing with them for years. I've learned something, so that's great.
Excellent.
Okay, unless there are any more questions, that's what we set out to do. Next time you'll be in the capable hands of Rupert. And if any of you do encourage people to watch his videos, because they're a good refresher, and it'll be a good refresher of his style. Download Windows Studio Code. Rue is a very good advocate for it. I've played with it based upon his just in the last few days, and I'm transferring over it to the suite I was using before, because it can do it has a facility that the previous software I was using hadn't. It allows you to type inputs into running it through Studio Code, which does save an awful lot of work.
I've used
It's
other
good.
IDEs, but a quick check. The VS Code does seem to be cross-platform, so I'll have a look at that.
Yeah, I used to use, up until last week, I used Sublime Text, which has this foible that you can't use the input command in it and input anything. So you're constantly commenting it in and out as you test it. So I've decided it's better even if it's from Microsoft. Any more?
Okay. Yeah, thank you, Andrew. Thank you, Richard, for the time you put into putting this together. A very good starting point. And as you said, Rupert will be with us next week, and same time, same place. Take care.
Thanks very much, guys.
Okay.
Thank you.
Very useful. Very useful.
Bye-bye now. Bye-bye.
Bye-bye.
Good.